I've taken some time out to work on a powerful agent that can solve some problems for me. Like many of you, I've used Claude 3.5 Sonnet and GPT-4 Omni, and I do find these tools useful. However, there are some aspects of the tools that I wish I could have as features. For example, the ability to do long-running research tasks. I'd like to give Claude or ChatGPT-4 Omni a research task and have it go away for several iterations to actually complete that task and come back to me. And I don't mind if that task takes 5 minutes or takes half an hour or even an hour to complete, as long as it's completed comprehensively. Now, I understand that artificial intelligence, especially in the form of large language models, is quite far away from that happening right now. But that hasn't stopped me attempting to lay down a framework or a tool that hopefully in the future, when we start to see the bigger and better models being released, should be able to do those types of long-term research activities. So in this video, I want to introduce to you Jar3d. Jar3d is an AI agent that I've created that makes use of meta prompting and also agentic RAG and chain of reasoning to complete your long-term research tasks. In this video, I'm going to be demonstrating Jar3d to you. Alongside demonstrating Jar3d to you, I'll be walking through the logic of how I built Jar3d. I'll be taking you through the concepts of meta prompting, agentic RAG, and also chain of reasoning. You'll be able to see the Python code and how I implemented everything there. As usual, Jar3d is open source and it will be available to you in the GitHub repo linked in the description to this video. So feel free to open that up and follow along. I envisage that in the future, Jar3d could be a useful tool for those of you that want a research agent or assistant to help you out with tasks like writing a literature review, writing newsletters, researching on a topic, or even if you're working internally in an organization and you wish to do some kind of agentic RAG over your internal documents and you don't want to have any access to the internet whatsoever, Jar3d could be adapted for that purpose too. Now, I'm not going to say Jar3d is perfect right now. It isn't. And that's partly why I'm putting it out there, because I'd like the community to get its hands on it and see what improvements could be made. I'm completely open to any suggestions to make the tool better for all of us. Okay, I'll start off by kicking off a demo of Jar3d to do a long-term research task over the duration of this video. And while Jar3d is performing that research task, I'll be going into the details about how Jar3d works. Hopefully, at the end of the video, we should have some output from Jar3d to demonstrate its capabilities. All right, let's get into it. As promised in the introduction, I want to start off by demonstrating Jar3d to you so you can see for yourself how it works. Now, Jar3d does perform long-running tasks, so I'm going to be leaving Jar3d to run whilst I do the remainder of this video. The setup for Jar3d is non-trivial. It does require 2 steps. So the first step is setting up the ingester server, and that's the server that takes in our URL and processes them, chunks them, and then prepares them for the agentic RAG that we need to do. And then the next step is setting up Jar3d itself. So that's choosing the model we'd like to work with and then running that through the PowerShell. So I'm going to show you both of those now. I'll be going into more detail about the agentic RAG and the specific technologies I've chosen to use there when I cover the agentic RAG code section of this video. So for now, just follow along with the setup and we can demonstrate Jar3d. So first thing I want to do is I want to open Docker. And do not worry, all of this setup information is going to be available for you in the GitHub README. You open Docker because you should already have the ingester server downloaded as a Docker image. So you need Docker for that. The next thing I want to do is I want to put up my PowerShell. So just for you guys that are not familiar with Docker, I have Docker running in the background here. So this is Docker up and open. And this is the ingester image that I need to run. So there's a command for that, and I'll show you what that is now. So I will grab the shell command, and this will be in the GitHub repo for you, as I mentioned before. The next thing I want to do is I want to open a Anaconda PowerShell. So I brought my PowerShell here, and you don't have to use Anaconda, it's just my preference. And I want to run that Docker image. So I'll do that by running this command. And what you'll see is if I navigate back to Docker and I go to containers, you can see this image is starting up here. So that container is actually starting up and it's beginning to run. Once it's up and running, you'll see the server is ready. So you can see this is where I can access my server. And just to give you an understanding, high-level understanding without going into too much detail, this server is a Java server. It's an adaptation of the Tika server, which is used to ingest things like PDFs, HTML, and chunk them in an intelligent way so that they can be used downstream for your RAG processes. And this runs completely locally. You don't have to send your data over to a cloud. So once we have our document ingestion server up and running, as I showed you in the last step, what we want to do is we want to start Jar3d. And the way you do that is by running Python M, and then you want to run agents Jar3d. So you want to make sure when you're running this yourself that you're in the root directory of the project, which is MetaExpert, and you want to make sure that any virtual environment that you're using is activated too. So Jar3d will kick off. And just to let you know, for the purposes of this demo, I am actually connecting to Anthropic. So I'm using Claude 3.5 Sonnet as the LLM behind the whole Jar3d workflow. I would like to try this in the future with an open source model. So I would like to try it with Llama 3.1 405 billion. Let me know in the comments section if that's something you'd be interested in seeing, because I will see if I can get that stood up on my own server and run Jar3d with Llama 3.1 405 billion, see how well it works with that. Okay, so I'm going to read what Jar3d is saying here, and then I'm going to talk through a bit about how Jar3d is working. So Jar3d says, hello, I am Jar3d from Braincube. Obviously, Braincube is my AI development consulting business. I use the chain of goal-oriented reasoning to help you refine your goals and gather aligned requirements. If at any point I stop using my chain of goal-oriented reasoning, add COGOL to your next prompt, and I will usually start again. Tell me, friend, what's the primary goal you're aiming to accomplish? And then it asks a series of follow-up questions. So chain of goal-oriented reasoning is an adaptation that I've taken from a project called Professor Synapse. Please go and check the project out. It's pretty cool. But essentially, it is a bit like chain of thought, but a more structured approach. So we get the model to ask us questions in order to update our goal incrementally. So it will fill in the gaps initially, and it will ask questions where there are knowledge gaps to refine and clarify things to make sure that it is updating the goal incrementally. And at the end of it, we should have a refined goal that we pass on to the meta agent, which will then be in charge of executing across all of the other agents in the workflow to make sure that we can hit that goal. So all we're doing here is refining requirements, basically, and it's going to ask us a bunch of questions aligned with this chain of reasoning adaptation style framework. And I'm going to get into the prompts for the chain of reasoning a bit later in this video. So let's work through with Jar3d. I want to write a TLDR style newsletter about the Llama 3.1 family of models. So obviously I'm asking this because it is not going to be in the model training data. So it's a good test for Jar3d. So I pass that information over to Jar3d. And what's going to happen from here is Jar3d is going to then ask me some follow-up questions. Now, note I have put a slight time delay in posting this information to the Anthropic server, and that's because I was reaching rate limits for some reason. I don't know why I wasn't getting throttled before, but I think I reached a stage with development where I was getting throttled. So Jar3d has given us a response. It says, excellent goal. Writing a TLDR style newsletter about the Llama 3.1 family of models is a great way to share concise, valuable information with your audience. Let's refine this goal and gather the necessary requirements to ensure the newsletter is effective and informative. Based on your goal, I've identified some initial requirements in the COGOL. Let's explore these further and add more to the specific details. What is the target audience for your TLDR newsletter? Are they AI enthusiasts, developers, or general tech readers? So these are good questions already. How long do you want the TLDR newsletter to be? Are we aiming for a specific word count or number of bullets? What specific aspects of the Llama 3.1 family do you want to highlight? For example, performance improvements, new features, or potential applications. All right, let's work through those. So what's the target audience for TLDR newsletters? So I'm going to say target audience is AI enthusiasts. Give my spelling, by the way. and engineers. So let's say target, if you, I say developers and developers. Right, so word count should be a maximum of 500 words, let's say that. And what specific aspects of Llama 3.1 family do you want to highlight? I want to highlight the specs of the model. I want to highlight the performance versus other SOTA models like GPT-4o and it's 4o like this actually, and Claude 3.5. The best, now I have done previous research on Llama 3.1. The best place to pull information for this Jar3d model or the Jar3d project is going to be from Reddit when it comes to performance information. And the reason is, as I was doing my research, I realized that a lot of the performance data is plastered in as pictures, as picture tables. Jar3d doesn't have the capability at the minute to process images right now. That capability can be built in, but it's not there at the minute. So it's not in the document ingester server that only deals with text, although it can process PDFs, but only certain types of PDFs. So what I'm going to say is the best place to pull the information about performance is from Reddit. I know this because I've been on Reddit and I've seen the tables there that are in text format already. There might be another source, but for now, it's Reddit. Let's say the model specs can be from official Meta blogs. Let's say that. Okay. So we're going to start updating these requirements. So Jar3d takes these requirements on board, processes them, and updates. Fantastic. So we have another message from Jar3d. Thank you for providing more details about your requirements. I've updated the code to reflect your specific needs for the TLDR newsletter about the family of Llama 3.1 models. All right, let's refine these requirements further and create more effective newsletter for your AI enthusiasts and developer audience. Are there any specific subreddits or Reddit threads you'd like us to focus on for gathering performance comparison information? Would you like to include any visual elements in the newsletter, such as charts, infographics to help illustrate the performance comparison or model specifications? Given the 500-word limit, how would you like to prioritize the content? For example, should we allocate more words to the model specs, performance comparisons, or potential applications? So these are all good follow-up questions. So are there any specific subreddits? I think there's a subreddit called R Local Llama, I believe. There is a subreddit called R Local Llama. I believe that's what it's called. I'm just going to double check for a second. Local Llama. Yeah, there is. So there's a subreddit called R Local Llama. I should know this because I think I'm on there quite a lot. And that should have performance information, hopefully. Let's hope we're not being too specific here. Would you like to include any visual elements? I would just like to include performance comparison metrics within a table. I don't want to include any infographics. So I don't want to include any infographics or any pictures or images. Okay. Given the 500-word limit, how would you like to prioritize the content? For example, should we allocate more words to the model specs, performance comparisons, or potential applications? Please allocate more words to the model specs and performance comparisons, applications are still to be discovered. That's because the models are new. But talk about potential applications. The other thing I want to include is let's send these in. Let's send these in as specs first. The other thing I'd like to include is I want to actually have links to these sources, so hyperlinks, so the readers can read more if they are willing to read more about Llama 3. So there we go. So we've got our specs outlined here. So you can pause this here to read. But I'm not going to read all of this right now. But what I'm going to do is I'm going to say, can we include hyperlinks to sources so that readers may read more if they wish? Now, obviously, you could be a lot more detailed with your specs and you can be a lot more specific, but this is really just for demo purposes. And that should update. It'll be exciting to be able to get the Llama 4.05 billion on Grok and see how fast we can actually go through this workflow. All right. So those are all the specs I'm willing to give over to Jar3d right now. And to kick off the Jar3d workflow, what I'm going to do is I'm going to run /end. And what that does is it tells Jar3d that I'm finished with the requirements gathering process. I'm happy with everything that's been put out. And I'm going to go end. And what should happen now is it should move out of the requirements gathering bit and move into the other parts of the agentic workflow, where we're actually going to take those requirements and start refining them to produce the newsletter. So here we go. So these are our requirements, right? A TRD asks our newsletter about the Llama 3.1 family of models for AI enthusiasts and developers. And you can see all of our requirements here. And that is what the chain of reasoning has done for us. It's actually incrementally gathered those requirements by asking us questions and filling that out. And this is passed on to our meta agent. And you can see the meta agent is actually processing this systematically through those agent nodes and making decisions about that. And hopefully at the end, if this works, because this is going to go on for about 30 iterations, you can set the number of iterations you want. Obviously, bearing in mind that this is accessing the internet and doing RAG on the fly. You can see that here, we're indexing pages. All the RAG models are local. So all of the models for doing the embeddings and doing the re-ranking are local. So I'm going to talk about the architecture a bit more. So this will run for 30 iterations until the model is satisfied that it's created a newsletter for us. So I'm going to pause it there, and we're going to come back to this at the end of the video once it's run to evaluate that newsletter. And you can see for yourself how well that has worked or how well it's not worked. Right. Let's move on to the next section where I'll talk a little bit more in detail about the architecture. All right. So you've seen the Jar3d demo. I think now it makes sense to try and fill in some of those gaps with some of the theory. Let's look at the Jar3d architecture and see how this thing actually works. So I've got a flowchart here representing the Jar3d architecture. So first of all, everything is orchestrated by LangGraph. And the reason I like to use LangGraph is because I find it to be one of the most customizable agent workflows. So I've experimented with a lot of agent workflows, Crew AI, AutoGen. I've used Agency Swarm as well. I've used LangChain. I've built my own custom ones. But what I find with LangGraph is I really like that approach of, setting this graph and setting the state and being able to control what agents do that way. And that's my preferred agent workflow now that I use. So I tend to build my agent workflows in LangGraph. I've done a detailed video on how LangGraph works, so please check that out if you are new to LangGraph. I'm sure that is going to be helpful for you. Okay, so this is how Jar3d works, and this is all orchestrated in LangGraph, right? So the first step of Jar3d is obviously that kind of adapted chain of reasoning approach. And you can see here what we're doing, and this was demonstrated in the previous step. In the demo, we start off, and Jar3d gathers the requirements. If the requirements are not adequate, it continues to gather requirements. And the way Jar3d knows the requirements are not adequate is that we do not press, or we do not type /end. So it will continue this iterative cycle of gathering requirements until we type /n, which you saw. So that requirements gathering process is there to refine the goal of the user. And technically, this could be any goal. I set my goal as writing a TLDR newsletter about the Llama 3.1 family of models that were released, but this could be any goal. It could be a research goal. It could be a goal to create a literature review. It could be a goal to create a holiday, for example. You could treat Jar3d as kind of a hospitality bot to recommend locations on holiday. So it's flexible in that sense. Once the requirements are adequate, and well, apologies as well, there's another use case. If you were to link this up to, I don't know, a code interpreter, technically Jar3d could be a software engineer, software developer gathering requirements as well. So you could adjust the prompt for that purpose. I think it's quite a flexible approach. So once Jar3d's gathered all the requirements, it's passed to the meta expert. The meta expert, I did a video on meta prompting before, so I'll link that as well, so you can review that video if you haven't already had a chance to look at it. But essentially what a meta expert does is it's a different type of approach to agentic workflows and large language models. Instead of you writing the instructions for every single agent in your workflow, you get a powerful agent to write those instructions for you. So my meta expert has access to an internet researcher. It has access to a writer, and it has access to a planner. So the internet researcher has access to a search engine. The writer and planner don't have any tools. They just are specialists in those areas, in planning and writing. What a meta expert does is it writes the prompt for the internet researcher to then go off and go and find the relevant sources on the internet. And the internet researcher, as a tool using agent, has access to a RAG tool, and has access to a document ingestion tool, and has access to a search engine tool. The meta expert will also write instructions for the writer to go and write something, or write instructions for the planner to deliver a plan. And those instructions that the meta expert writes are all based on the stuff that it receives from Jar3d. So the requirements that it receives from the first step of Jar3d, which was to refine our requirements. The meta expert uses chain of reasoning as well. So it does use a chain of reasoning to decide how far along it is in processing that objective that it's received from Jar3d. And I find that this is a great way to actually get the meta expert to stay on track. Right. There is a router as well, and the router will decide, based on the instructions the meta expert gives, whether it's directed to a tool using agent or a non-tool using agent. So you can see the tool using agent is the internet expert, so the internet researcher with RAG, and the non-tool using agents are the writer and planner. They will deliver their results, and the meta expert will review, and it will decide whether it needs to revisit the information and gather more detail and then provide other instructions, or it will decide whether it can actually deliver a final output to the user. So that is the approach, simply put. Now, I will warn you, the Python code for this is pretty extensive. So let's pull up the Python code just to give you a bit of background. So I'm going to pull that up in the back here now. So let's have a look at the Python code. This is in my VS Code instance. So when you're working through this project yourself, you'll find this in the file Jar3d.py. So as I said, we're using LangGraph, and the first thing we want to do in LangGraph is actually define our states. And our state is just where we keep track of everything that's happened in the agent workflow. So all the conversations we've had with Jar3d and requirements gathering, we can write that into a state. So we have a requirements gathering part of the state. The meta prompt is what's delivered by the meta expert, so we can write that into the state as well. We can also record conversation history. We can record the things that come out of our different experts. So from our planner, we can record a plan. We can record research from our internet researcher. We can record writing from our expert writer. We can record user input, anything that we want to use later on in the state. And the good thing about these states is we can access any element of this state at any point in the agent workflow, as long as it's been updated with something. We can access it and feed it back into our meta expert or whatever agent we want to. So that's why I like LangGraph, because of that state, as well as having an agent graph where we can direct the workflow. We also have a state where we can actually record the activities that have happened in our agent workflow. So the way I've done this, I'm not going to go through every function, but I will show you the classes, because that will help to solidify some of what's happening here. So we've got the first class Jar3d, and that is the front end bit that gathers our requirements, and that's defined here off the back of this base agent. I would advise you to have a look at this code yourself to dive in more detail. So we define Jar3d here. And then we have our meta expert, which we defined here. We have our node tool expert, which obviously is just going to be any expert that doesn't require any tools. We have our tool expert. And then lastly, we have our router. So of all of these, the tool expert is the most complex to implement. And the reason being is because there's actually many stages to the tool expert. So have a look at this for yourself. And if you want me to do a more detailed video on these experts themselves and go into more line by line what's happening with the code, let me know. There is a lot to cover here, so I won't be able to go into every single detail. But the tool expert is complex because it actually requires quite a few things. So there is a search engine tool. So the search engine is obviously how we access the internet. Then we have a document ingester tool. So that's stood up locally, and that takes a URL that we pick out of our search engine, and it can ingest it, and it can deal with things like PDFs. It can deal with HTML, Markdown, you name it. It can deal with a wide variety of paths. So that's using a modified Tika server from the open source project LLM Sherpa. Check that out as well. It's a good project. I think in a later video, I'll go into more technical details about the code and the setup for this thing, because there is a lot to it. I won't be able to cover everything in this video. And there is a RAG component too. And a RAG component is RAG on the fly. So every time we pull a URL, we do document ingesting, intelligent chunking, and then we do RAG on top of that. So when I say RAG on the fly, what I mean is the tool itself will do the document embedding. So once we've chunked that document, it will embed it with a local model, and then it will do re-ranking with a local model too. And once we have our re-ranked documents, that is going to be passed into the context as research for our meta prompting agent. Yeah. Again, let me know in the comment section if you want me to do a deep dive on the technical aspects of this. So that's our tool using agent. And then lastly, we have our router, and the router, plays a part in that diagram to either route to the tool using agent or route to the non-tool using agent, depending on what the meta prompter gives. Lastly, if you are using this Jar3d, if you're using this Jar3d project, what you want to do is you want to navigate down to the bottom here, and you can select from a choice of different models and services. So we use Claude 3.5 for that demo. If you want to use OpenAI, you would just comment this out and uncomment the OpenAI agent quarks, and you can go for that. So I've tested this with VLLM. So VLLM is using an open source model that you host yourself. I haven't had a chance to test with Ollama yet, but you can give that a try and see how well it works. My hardware is just not good enough to really run Ollama models for something this complex. So I haven't had a chance to test with Ollama yet, but on a previous version, I know it worked. So you give it a try and see what happens. I know it works with Grok. The thing is finding a model that's capable enough, and the 4.05 billion models are not available to the general public yet, unless you are fortunate enough to be part of the few people that have a paid subscription to Grok. There were some bugs with Gemini, so I haven't had a chance to get around to debugging that yet. And then lastly, what you want to do is, or what I've done is I've created the agent graphs themselves, and this determines the order of operations. So obviously we start off with Jar3d, then we have a meta expert, router, node tool expert, and then we end the chat. So the entry point is Jar3d, and the finish point is the end of the chat. And then we want to define the edges. So the edges indicate which agents kind of speak to each other. So Jar3d speaks to the meta expert can speak to the router, and then the router decides where it goes, whether it goes to the tool expert or to the node tool expert. And that's set by a conditional edge. So we have this conditional edge here with the router, and we've got a routing function that decides based on the output from the meta expert whether we're going to go to the tool expert or the node tool expert. The tool expert can go, tool expert obviously reverts back to the meta expert, and the node tool expert reverts back to the meta expert too. And then the way we obviously end this is if the meta expert decides, hey, I'm going to deliver a final answer, and it delivers its final answer. And then in that case, the router can route to the end. So instead of going to the meta expert or instead of going to the tool expert or no tool expert, it'll deliver a final answer, and the router will route that to the end. Okay. Lastly, you want to set your recursion limits. So we are operating over 30 iterations. I see in an ideal world where AI gets really good and we have massive context windows, or we have the ability to manage those context windows more effectively. So remove things from the context that are irrelevant and things like that. So we don't necessarily need an infinite context window as long as we just build up relevant context in that window. You could set this recursion limit to something really high, like 1,000 recursions, and you'll go off and have a cup of tea and come back and have something comprehensive written, like a comprehensive literature review, for example. It's gone off and done all the research for you. So that's kind of what I see for Jar3d in the future, the ability to set those long-running tasks. That's the agent workflow in Python. I haven't gone into detail about the RAG tool, and I haven't gone into detail about the prompts themselves. I will show you a little bit about how the chain of reasoning stuff works next, because I think that's important to see, and it's something I can cover in this video. I'll probably do another video on the technical aspects of the RAG tool, how I did the RAG on the fly and all that type of stuff, so you can see for yourself. But the GitHub repo is there available for you, so you can review that code for yourself, and you'll see how everything works in there. So let's look at the chain of reasoning stuff in a bit more detail. So the way I'll do that is I'm going to navigate to the prompt. So I've called it requirements gathering prompt here. And what I'll do is I'll copy this out, and I'm going to paste it in a custom GPT, because I found that the best way to experiment with this type of prompt is actually through a test custom GPT that I make. So I'm going to show you that now. By the way, a neat trick that I have started implementing is that I write all my prompts in Markdown. So first of all, it makes it easy for me to understand what's going on with the prompts. That's obviously a big advantage. You know, if it's easy for me to read the prompts, I can edit them easier too. Secondly, a lot of models were trained on heavy amounts of Markdown. So it turns out our models are quite good at interpreting Markdown. And lastly, you can express things in Markdown in ways that you can't express in just pure text. So for example, you can put things in bold. You can link concepts. So by putting square brackets around them, it shows the concepts are linked. Titles are by the hash. So we can put titles by the hash. We can express things programmatically, so Python with 3 dots, but we can also express flowcharts. So we can use things like Mermaid to express flowcharts. So yeah, Markdown is a very versatile way of writing your prompts. And if you've got a tool that you can render Markdown, so I use Obsidian, I write all my prompts now in Obsidian and then move them later on into VS Code when I'm ready to actually get them running. Obsidian is great because it renders Markdown. All right. So I'm going to create a custom GPT to show you how this chain of reasoning prompt actually works. So this is the prompt I used initially for the requirements gathering part of Jar3d. So I've put a prompt in. So this is done automatically when you enter the Jar3d workflow, but for this purpose, you have to say /start, and there you go. So it says, hello, I'm Jar3d from BrainCube. I use chain of goal-oriented reasoning to help you define your goals and gather aligned requirements. At any point, I stop using my chain of goal-oriented reasoning, add co-goal to your next prompt, and I will usually start again. Tell me, friend, what's the primary goal you're aiming to accomplish? So this might look familiar to you. So just so you can see how this updates in real time, I will put in, I would like to write a TLDR style newsletter about the Llama 3.1 family of models. So you'll see how it actually updates that co-goal. So chain of goal-oriented reasoning. it updates that with those requirements. And as it starts to ask more questions to refine it, what it's going to do is it's going to continue to update this Kogor matrix. And that's actually what we provide to the meta agent once we have decided that we have updated it enough. So I'll say, let's answer one question. I want to highlight the performance of the models versus SOTA. I want to use only reputable sources, right? Let's see. So there we go. So you can see how it's being updated. The Kogor is being updated. So you're saying use information from reputable sources and then highlight performance of Llama 3.1 models compared to SOTA. And then when I do eventually press end, hopefully this works in this custom GPT. There we go. So we deliver this Kogor output and it says, thanks, your goal-oriented requirements have been delivered to the agent. So this is what would be passed on to the meta agent. So it really helps you refine those requirements. And that's what essentially we were doing at the start when we were using Jar3d to refine that request about the newsletter. All right. We've seen how the Jar3d requirements prompt works. So that front end prompt where we're gathering the requirements and refining them. I want to show you what that looks like when we've rendered it in Markdown so you get a better idea. Of course, it's going to be available to you in the GitHub repo so you can read it for yourself too. And I also want to show you what the meta prompt looks like because those are the two main prompts that make Jar3d work. So first, let's look at the Jar3d requirements prompt. So we have our mission, which is to act like Jar3d, a solutions architect, assisting me in writing clear and comprehensive requirements. So we can see how we've kind of linked everything across here by putting them in the square brackets. Preferences and context. Then it says Jar3d has the power of chain of goal-oriented reasoning, Kogor, which helps reason by running your thought process as code interpretation by using your Python tool to prepend every output in the code block with the Kogor. So that's our Kogor dictionary. And actually, if you do get this to run, you can get this to run as a custom GPT. And if you do get it to use the Python interpreter tool, it's quite powerful because it actually adds it programmatically. It does two things. So it hides this Kogor output and it also serves as a separation from the output. So let's say if we weren't feeding this into Jar3d and we just wanted to use it as a custom GPT that kind of sits on top of the ChatGPT environment, it hides that, the code, the programmatic part of it, and it actually will deliver the goal to you. But in this case, we just wanted to refine requirements. We don't want it to actually deliver the newsletter. So then you pass the instructions in, and I'm not going to read all of this stuff, but you can read through this in your own time. You give it some traits, rules, and then you show how it works. And then you show how, if we want to give a final answer, we push end, and it will insert that Kogor for us, and that's what we'll take and pass on to the meta agent. So I know that was a quick whistle-stop tour. We are on time, so I don't want to spend too much time looking at this. So I don't want to spend too much time going over this. Apologies. But you can look at this in your own time through the GitHub repo. That's why I make all of the code available to you. There's just too much to cover in one short video. Then we can look at the Jar3d meta prompt. And the meta prompt follows a similar style. We give a persona. So we say you're a meta agent, super intelligent AI with the ability to collaborate with multiple experts to tackle any task and solve complex problems. And then we have our objective. Objective is to collaborate with your team and produce work based on a comprehensive set of requirements you will receive. And we say, when you receive the requirements, it's going to be in the form of this requirements tags. So we wrap all our requirements in these tags so the model knows, or the meta expert knows which tags, which sort of requirements it needs to focus on. So it does use chain of reasoning here. Like I said, I adapted chain of reasoning I've taken chain of reasoning from Professor Synapse project. So check that out, get you a better understanding of chain of reasoning. But it is slightly different from the Kogor approach I use for requirements gathering, because this time it's checking our progress towards the requirements that we have established from Jar3d in the first instance. So the chain of reasoning is set out slightly differently here. We have our goal. And this is obviously flexible. It's completely down for the meta expert to decide what that is. We have our progress towards the goal. We have user preferences, which will all be gathered from the requirements, adjustments, and then strategy, expertise, verbosity is like the level of output that the meta expert is going to deliver to its experts. So it could be a verbose output, it could be less verbose. It's just a way for the meta expert to think about what it does before it delivers those instructions to its experts. So everything is appended. All instructions are appended by this chain of reasoning, this call, before we deliver an output. And then we talk about achieving our objectives. So we produce two types of work. Type 1 works, which are instructions you deliver to the experts, and type 2 works, which are final responses. So instructions you deliver to the experts look like this. So you can see we have our chain of reasoning here. And then we have our instructions to the meta expert. And we have a verbosity score there of medium. Should be low, actually. So probably a little bit of mistake in the prompting, but doesn't matter. It's not causing any huge problems, because that's not verbose at all. That's a tiny prompt for the internet expert internet researcher. But that's essentially the type of work that the meta expert does. That's one type of work. That's type 1 work. So we have our chain of reasoning there, which is kind of like think before you act. So it's thinking out what we need, has its goal, and then it delivers instructions to the expert internet researcher. And it will, remember, large language models work auto-regressively. So because it's delivered that chain of reasoning, it will have its thought process mapped out before it then communicates something to the internet researcher. And remember, that's why when you ask models to think step by step, the papers show that they produce a performance improvement by you asking them simply to think step by step before delivering a response, because it actually outputs its own reasoning trace, and that's able to guide it to deliver better responses. It's the same with this chain of reasoning approach. It's just a more structured way of doing it. Instructions for producing type 2 works. So type 2 works are final responses that the model gives. So you present your final response as follows. You have your chain of reasoning, and then you have your final answer. And again, the idea is you deliver a higher quality final output if you have your chain of reasoning there first. And then there's some information about the experts. So we have the expert internet researcher that has access to search engine and all that type of stuff. Has some rules about working with the expert internet researcher. Then you have the expert planner. And you have the capabilities of your expert planner and some rules about working with the expert planner. And then you have your expert writer capabilities and rules about working with the expert writer. And then we have our expert work. So our expert work is accumulated in the state. So remember the state object I showed you in Python. The expert work is accumulated in the state. So we have work for the internet researcher. We have a separate key for that. We have a separate key for the writer. We have a separate key for the planner. So all of that expert work is accumulated, and that's fed back to the meta expert. And then we have suppressed practices for working with the experts, and then important reminders. And I find that keeps the meta expert on track, because what we're asking the model to do is complex. We're asking it to orchestrate many different experts. So it needs to understand what each expert can do and the right time to orchestrate it. So this is quite a sophisticated prompt. I implore you to have a look at it yourself and just get to grips with it, and give me any feedback on the prompt and maybe how you do it differently, or whether there's a different approach to this entirely. That's it. This is Obsidian. So this is the tool I use to write my prompts. And you can see it's well rendered here. It's a lot easier to read than reading it in VS Code. So that's another tip I drop to you. If you are writing prompts for large language models and you haven't tried writing them in Markdown yet, please give it a shot. It is a game changer. It's been a game changer for me. And use a tool that can render Markdown. So you can even just do it on GitHub if you want, or you can do it within Obsidian, which is like real-time rendering. So it's just a lot easier to see. So hopefully that gives you a good understanding of how Jar3d works. I know I haven't gone into detail about the stuff about RAG on the fly. I will do that in another video because we are pressed for time, and it's time to actually review the newsletter. So I'll be doing that next. I'll show you the agent chain and how that's worked through, and then we can review the newsletter and see if it's any good. And then I'll give you my feedback on Jar3d itself and pitfalls that I've experienced building Jar3d and things that I think could improve the model and where I think it can go next. So stay tuned for that. So my fingers were crossed throughout the video, but we actually have a final response delivered from Jar3d. Now I'm going to scroll right up to the top so you can see exactly what the workload has been from Jar3d. So this is all the research Jar3d has compiled, going onto the internet, finding sources, doing RAG on the fly, tokenizing that, and then putting that in the context for the meta expert to then write its instructions. And this is all captured in the state. So what you're seeing here, all of this writing here, is the state graph, or this state object that I'm using, obviously, because I'm using LangGraph, and that's recording all of the research that all of the different experts did through this Jar3d workflow. I'm scrolling right up to the top to see how far we can go. So I can't go right to the top where we started the Jar3d workflow because there's only a certain amount of words that this PowerShell window can show you. But you can see how Jar3d is working to update the state. So you can see the meta prompt, and we can see the goal. So we have the chain of reasoning there. And remember when I showed you the prompt for the meta expert, it always appends a chain of reasoning. So we've got the goal, write a TLDR style newsletter about the Llama 3.1 family of models for AI enthusiasts and developers. And then we have progress towards our goal. At this point, it's 0. User preferences. We have all of this stuff in here. And then we go on to go through that. So we have the conversation history there. So you can see where we're gathering information from the internet, because you should see here, we have a source that we return. So there we go. There's a source there. So I know this is difficult to read, so I'm not going to go through everything in detail, but just know that what's happening here is Jar3d is working through all of those different experts, visiting the internet, gathering information according to our goal. And you can see this is right because you can either see scores returned here. So these are similarity scores returned for each bit of context that we're doing retrieval on from the internet. So we just keep going down, all the way down, and this happens over 30 iterations. It's different sources. So remember, I said we want to visit our local llama. If you run back to the beginning of the video, you'll see that was one of the stipulations I had. So it turns out we've actually started that with the RAG tool, visited our local llama, pulled some information from there, managed to get grab some information from there and add it to the retrieved context. So this just grows and grows and grows because we let the agent workflow, we let Jar3d do this over and over again until Jar3d is satisfied that we've actually gathered enough information to write our newsletter. So this is essentially like reading tons and tons of websites. Well, not tons and tons, but reading context from a lot of websites and putting it together to give Jar3d the ability to answer and write a comprehensive newsletter at the end. And this is our newsletter. This is where we deliver our final response. So we progress with our chain of reasoning. So what's interesting here with Jar3d is the progress towards the goal is stated as 0. That's probably something that I need to work on with Jar3d because it should be progressing towards 1 because we have actually written the newsletter, but maybe this is saying something. Maybe Jar3d feels it needs more iterations to actually progress towards that, towards moving towards the goal. So maybe it needs more iterations. We've got our strategy here. So maybe it didn't achieve everything it wanted in the strategy in the number of iterations we had, which was 30. But then we actually deliver our final answer, and this is the newsletter. So I'm going to post this. I'm going to copy and paste this into Obsidian so we can see how it renders out in Markdown. So I'll copy everything here. Let's do a Control-C, and then I'll open up Obsidian, and I've got a test newsletter here. So let's paste our TLDR newsletter. So here we go. Meta has released Llama 3.1, the latest iteration of their open source large language models family. Here's what you need to know. So that seems like a good start already. Let's test the links. There we go. So we do link to the Llama 3.1 blog, which is fantastic. Key features: open source, fully customizable and downloadable, multilingual, supports 8 languages. I wonder if that's true. Extended context, 128K versus 8K in previous. So that is actually true. I know it's 128K context. And then we have multiple sizes. So we've covered all the sizes, 8 billion, 70 billion, and the big 405 billion model. Now, performance highlights. So Llama 3.1 405 is competitive with leading closed source models across various tasks. Here's a quick comparison. So we've even got the table that I asked for. So I don't know how accurate these numbers are. What I'm going to do is I'm going to save this newsletter down, and you guys can have a look at this yourselves to see how accurate these numbers are. I have known Jar3d to hallucinate some things, so it would be good to verify the accuracy of this stuff. According to recent benchmarks, Llama 3.1 outperformed Gemini 1.5 Pro and GPT-4 on simple bench, though Claude 3.5 still leads overall. So let's just have a look. Let's see if we are. So we have gone to Reddit. Amazing. So Llama 3.1 on simple bench beat Gemini 1.5 Pro and GPT-4, but Claude's still on top. So it's just pulled out verbatim from Reddit, and that's fine because if you remember, that's something I asked it to do. So that's okay. I'm satisfied with that. So then we have potential applications, synthetic data generation, which is something that's been talked about a lot, and model distillation, if you've listened to anything about Llama 405 billion. Long form text summarization, multilingual conversational agents, and coding assistance. Cost and accessibility, Llama 3.1 models offer significant cost savings compared to GPT-4, with some estimates suggesting up to 50 times lower costs for input tokens and 76 times lower for output tokens. So then developer-friendly features, we've got Llama Guard here, Llama Guard free. Let's just make sure this is not hallucinated. So introducing Llama 3.1. So this is actually linking us back here. So let's see if we see anything about cost. Those models are more cost effective. Llama offers lowest cost per token in industry, according to. Okay, so it is talking about low cost. I don't know where it got those numbers from. Maybe those numbers are hallucinated. Let me just double check. It says 50 times lower cost, which is very specific. Let's just see if we've got that in here. So I can't see where that cost thing is coming in the article. I can't see where that's coming in, but maybe it's coming from somewhere. So yeah, this is obviously this is one of the disadvantages of using RAG. Even RAG doesn't prevent hallucinations sometimes. That's why it's always important to read the outputs that come from these things. So then we have developer-friendly features. So we have Llama Guard. So I already went over that. Prompt Guard. Let's see if Llama Guard is mentioned at all. I'll pull this over again. I'll just type in Guard. Yeah, there we go. So we have Llama Guard free, and we have Prompt Guard mentioned as well. So it's managed to pick that out as developer-friendly features, which is pretty good. And then open source sample applications. Cool. All right. So what's next? Meta hints at upcoming features like longer context lengths and expanded capabilities. The Llama Stack API. So I have heard of this. So that is Llama Stack on Markdown. Docs. This is interesting. So this looks hallucinated. This looks hallucinated because we've mentioned the Llama Stack API, but there's actually nothing here. So yeah, that's definitely hallucinated. So we have the Llama Stack API is also in development. Although I know the Llama Stack API is a real thing, but I think it's hallucinated the source here. So we could do a little bit better on making sure that we're not hallucinating sources, but just to make sure that we actually, yeah. So the Llama Stack API is a real thing. We've just hallucinated the source, which is a little bit annoying. Graceful comment on a standard interface. We will hope to make it easier for third-party projects to leverage Llama models. There you go. So the Llama Stack API is a real thing. With over 300 million downloads of Llama versions to date, the open source AI revolution is gaining momentum as developers explore Llama 3.1's capabilities. We can expect innovative applications and further advancements in accessible AI technology. For a deep dive into Llama 3.1's capabilities, check out this comprehensive analysis. Now let's see, do we have something? Llama 3 70B versus GPT-4 comparison analysis. Right, okay, so this is Llama 3. This is not actually Llama 3.1 as we want. So that is another hallucination. But it's not bad. It's not bad. It's getting there. Obviously, a lot of work to do in terms of making sure that we're not hallucinating things that aren't in the actual sources that we pull. And a lot of that is to do with the retrieval aspect and probably to do with the prompting. But ultimately, hallucinations are there to stay in large language models. And the longer context you ask it to return, the probably the more likely you are to see hallucinations. Just to give us some comfort, what I would like to do is I'd like to ask ChatGPT to do the same thing and see what type of newsletter we return. And I'm asking ChatGPT because Claude 3.5, as far as I'm aware, at the time of recording this video, doesn't have internet access. So let's ask ChatGPT to do the same thing and see if we return anything that is solid. So I will provide the instructions. This could be a little tricky, actually. And the reason is I'm not sure we're going to have access to that initial chain of goals, instructions. Let's just have a look. Meta should be under the user input, actually. And fortunately from us, we always keep everything in there. So we seem to have lost it. Start is the user input. And then conversation history. It is buried somewhere in this conversation history. Text llama 3. And bear with me. I think I should be able to fish this out if I search for Kogor. So if I do a Control F and go Kogor, there we go, found it. So this is our Kogor. Let's see if I can grab everything I need within the Kogor. Here we go. Grab everything in the Kogor. Control C. And let's paste that here. There we go. So it looks like we've grabbed everything. And just to show you, that's the Kogor there. We won't worry about the new lines and stuff because I think ChatGPT should be okay interpreting that. But essentially what we're doing is I'm giving ChatGPT the same instructions that I gave to the Meta prompt or Meta agent, Meta expert in the Jar3d prompt. And let's just see what ChatGPT can return. So obviously expecting it to be faster, but also expecting it to be a lot more generic and yeah, hallucinating a bunch of stuff just based on those instructions as well. So yeah, and those links, what are local llamas clickable, but all of the other links are not clickable. So even if we said something like, you know, use sources from the internet, just to make it fair, let's see what it'll come back with. So it is browsing the internet now. It's looked at 4 sites, 3.1, 80 billion. It's still got the model specifications wrong. So, and it's got the models themselves wrong as well. So yeah, so Jar3d does offer an uplift on this based on those instructions. Obviously, you could probably play around with this and get it to output a decent-ish newsletter. But I think that approach of doing that on the fly RAG and making sure that we're actually retrieving the relevant context and then coming back seems to be this approach of just asking ChatGPT to generate it, even though it has internet access for now. I think even the newsletter itself is probably a little better written as well. This seems just to take that generic approach that ChatGPT just takes all the time. And yeah, this is wrong. This is hallucinated. So we know that the models have a context length of 128K tokens. This is literally saying it has 8,192 tokens, which isn't true, and makes me doubt a lot of these other numbers too. So that's just for those of you that don't get the uplift that Jar3d brings compared to just using ChatGPT. That's the uplift, using first of all that chain of reasoning to get the requirements. So chain of goal-oriented reasoning to get requirements and fleshing out your requirements. Obviously, ChatGPT doesn't do that for you, although you can prompt it to do that for a good system prompt. And then passing that to the Meta agent workflow to actually work through that over a number of iterations to pull the relevant information from the internet, do some RAG, and store all of the relevant context until there's enough information to deliver on your goal. And that's what we saw there at the end. Okay. I want to talk a little bit about Jar3d in terms of the limitations that I've observed and things that you should be aware of when you're using Jar3d for yourself. So stay tuned for that. I want to talk a bit about some of the limitations around Jar3d right now. First of all, I want to say that it's even amazing that something like this is possible because an iteration ago, we had models like GPT-4. Sorry, apologies, not ChatGPT-4, GPT-4. But if you notice, the context length on GPT-4 was around 8K. So it was the most capable model. But actually doing something like a Jar3d, where you're retrieving a lot of context from the internet, wouldn't have been possible with GPT-4 because of the small context window of 8K. As we progressed, we saw open source models extend that context windows to around 32K. And now we have state-of-the-art models that have context windows of 128K. So that is, we're talking the Llama 3.1 405 billion model now, GPT-4o. And I believe, I'm not completely sure, but I think Claude 3.5 has a similar size context window. And that really makes these agentic workflows possible because, as you saw from the PowerShell, you are gathering a lot of context. And that brings me to my first limitation. You can set the number of recursions, so you can set the number of times the agent workflow works through, but eventually it is going to crash out if you extend past that context window. So if you collect so much research that you're extending past the 128K context window, it will crash out. Obviously, there's a cost to the number of recursions you do, because if you're using something like a proprietary service, so if you're using ChatGPT's, OpenAI's GPT models, or if you're using Anthropic's Claude models or whatever, Gemini, Grok, you're going to pay per token you use. So you're going to pay per million tokens you use. So the more recursions you have, the more you're going to pay. But I'm sure that if you built agentic workflows before, you're already aware of this. Then if you're using open source models, pretty much I've tested this with the 70 billion models, and I cannot get the workflow to converge. It simply does not know when to deliver a final response. And that's because I think the 70 billion models, the way they are now, they're not really designed for agentic workflows, especially complex ones like this, where we're using meta prompting. There's RAG components to it as well. We're using that first part to define requirements. I've tried it with the 70 billion models. I've even tried it with, the Llama 3.1 billion model, and I couldn't get it to converge. So not 3.1, 70 billion model, I couldn't get a workflow to converge. So I don't think those models are ready yet for this type of workflow, but I do have high hopes for the 405 billion model that was recently released. So the 3.1, 405 billion, I think it's around a model that size that actually makes open source agentic workflows possible. So a tool like Jar3d, equipped with the 405 billion model, could work inside an enterprise, or could work inside an environment where the data privacy is of the utmost concern, as long as that environment had the resources to host that model. So as long as they had, a few dozen NVIDIA H100 GPUs available, I'm sure you could stand up several instances of that model and serve your whole organization. And a tool like Jar3d could work alongside that and help you to be like a research agent, go through your entire internal PDFs without ever leaving your local setup. So without ever having to go to the internet, or even if it has to go to the internet, it's never sending any of your data out there. It's just pulling data in. So a tool like Jar3d could be useful in that sense. And what's made it possible is the release of this Llama 3.1 405 billion model, which seems to be, from the benchmarks, competing with the proprietary models available. The limitations of Jar3d. So a lot of work still needs to be done. And that's why I'm opening it up to the open source community. I am putting this out there. The code is available for you to pick apart and interrogate yourself and take and do whatever you want with it. I think one of the things I noticed was that I could only get consistent or somewhat consistent results with Claude 3.5. So really the model needs to be performing at that level to actually get this workflow to do anything meaningful. I managed to get it to work with GPT-4 Omni sometimes, but other times, for some unknown reasons, GPT-4 Omni just doesn't play ball and doesn't work too well with GPT-4 Omni. So, that is one limitation of Jar3d, but it is expected because it is a mega complex workflow, as you've seen. I also have some suspicions that the initial requirements gathering bit could be done a little bit better, because sometimes the output of the requirements gathering is to gather more requirements rather than direct instructions for the meta agent. So for example, I've had it, and it's usually with GPT-4o actually that this happens, where I've put in my requirements, and then the output of that requirements conversation is, for example, if the requirement was to write a TLDR on the Llama 3.1 models, the output of that requirements conversation has been, give me instructions to write a TLDR on Llama 3.1, or give me requirements to write a TLDR on Llama 3.1 as the top goal. And it shouldn't be that. It should be write a TLDR on Llama 3.1. That's what it should be. And I'd found that problem less with Claude 3.5 and more with GPT-4o. The RAG component is something I built fairly quickly. And I know there's plenty of room for optimization on the RAG component. So this is first of all, so when I talk about the RAG component, I'm talking about every aspect of the RAG pipeline. So first of all, using the LLM Sherpa, which is an open source project, and it uses a locally hosted adaptation of Apache Tika server, which does document ingesting and processing and does intelligent chunking. So a way to improve that is to also include OCR in there. And OCR can make sure that you're also pulling images as well. So you can use OCR. And that's if you wanted to keep things completely open source and you didn't want to, I don't know, I'm using LLM Sherbet so I can keep things completely open source, basically. And I didn't want to use an external service. But I think if you connect to OCR, then you're starting to use proprietary technologies, unless, of course, you're hosting your own vision model to do that. So that bit could be improved because you could use a better you could use a better service for intelligently chunking documents that you retrieve either locally or from the internet. So you could use a better service there. The RAG, the embedding aspect could be improved. So we could use better embedding models. I just used the one that was relatively cheap in terms of computational cost. And so it's relatively fast because I'm going to be doing all this locally. My laptop hasn't got amazing specs. So I just used the one that would work on my laptop, basically. And I'm just using some basic retrieval. So I'm doing the embeddings. I'm embedding the document chunks and then doing some retrieval over that. And then I'm doing re-ranking on top of that. And I'm just using a basic re-ranking model again. And for those of you that aren't aware, what a re-ranking does is there's two things. There's biencoders and cross-encoders. And I believe biencoders, my memory's a little foggy on this, but biencoders allow you to do the first initial ranking, and they work really quickly, but don't give you the best ranking for your retrieval. And then cross-encoders are slower, but give you a much better ranking against your actual retrieval query. So it's best practice to use both. You first do the initial step of retrieval, and then you re-rank with a cross-encoder. So that's what I'm doing. And that whole pipeline could probably be optimized as well. And that may improve the results of Jar3d. Some things to explore, I think, down the line, I'm not sure these things exist yet, is if there's a way to intelligently manage the context that's in there. So can we start like dropping things out of the expert research that shouldn't really be in there, that aren't relevant to the overall goal that we're trying to achieve? So maybe there's another re-ranking thing there that we could do to drop things out, but also that adds latency to the system. If you're asking it to do something sophisticated, like a literature review, that maybe you give it 1,000 terms to do or something, maybe you don't mind if there's a little latency in there, as long as the quality of the output at the end is great. And the way I see Jar3d is, it is kind of taking these long-running tasks and refining until you get a quality output at the end. So if that does take a little bit of time, doesn't necessarily matter as long as the output is of high quality. And I think that's kind of the appeal of a tool like that. Let me know your thoughts in the comment section about Jar3d. Give it a try yourself. All of the instructions for setup are going to be in the GitHub README, so pay attention to that. I'll also include a few notes, and I'll include a link to that newsletter that Jar3d wrote in his tutorial, so you'll have a chance to read that for yourself. I'd love to get your feedback. Let me know your thoughts in the comment section. And once again, if you like this content, remember to subscribe to the channel for more AI engineering content. Reach out if you need any AI development work, or if you're seeking to build any tools or consultation, reach out to BrainQ. Thanks for tuning in, and I will see you on the next video.